Hey guys, welcome back to this video. In this video, we will be focusing on processing heart attack dataset. The goal here is not to teach you how to process the data, but give you the mindset that is required to perform EDA and what are the nuances that you need to understand while performing all those things. So I will be sharing you my experiences as well as we will look at how to load libraries and dataset. Then we will look at how to perform EDA in a very good manner. Then we will create pipelines for data processing, and finally I will share you some resources that will help you to get started as well as work along in some of the projects. So with this, let's start today's session. So first thing first, let's load libraries as well as dataset. So if you can see, here is our heart dataset, and here you can see that we have gender, age, H tension, any heart disease, never married, occupation, lives in, glucose level, BMI, smoking status, and heart attack. This heart attack is our target level as well as rest of them are features. So with this, let's load our libraries as well as dataset. First of all, we need to import few libraries. So I will be importing pandas as PD and importing numpy as NP. Now let's load our dataset. So we all know that it will be a data frame and we have to load it using pd.read_csv. The file name that I'm going to use is the heartattack.csv. Now we will check few samples and you can see that here is our dataset which we saw earlier also, right? So there are many things which we need to handle, and here are a few of the columns description. So read that before moving on because it will be very good. Now let's check the shape of the data. That means how many column and rows we have. So df.shape. Don't add any brackets, it will not work, it's an attribute. So here we have 4000 samples and 11 features. Okay, so 11 represents the column and 4000 represents the row. Now let's check what are the data types. So data types means we can use df.info. Why we are doing this is because later on it will help us to fix things. Like you can see that here there are 4000 entries, right? But here in DMI we have 3851 entries only. However, in our gender, age, H tension, all these, we have 4000 null values. But it is not always that this will be 4000 values only. We have to check other things also before saying that yes, these are actually 4000 values. Also, there is a D type. So wherever there is an object, it can either be a date time or a string value. So we have to take care of that also. And if there is a float 64 and int 64, that means it is an integer value. So these all things you can get an idea about. Okay, so now once we have done with this and we have seen that there are unknown values, empty values, all those things are there, we need to perform our exploratory data analysis or EDA. It is one of the important steps before processing our data because we need to make sure that our data is in a good format before data processing, which will be fed to the model. So let's look at that EDA part first. So before moving on to EDA, I would like to clarify that these all questions that you see, think of them as your questions in your mind, what you should actually ask in a particular EDA process. That will give you a more insight on how to go about it. So unique values means non-repeating values, and if the data type is numeric, which we denote as D type, then look for the negative or impossible values like 1e minus 14 or something like that. And if data set is categorical, you have to look for unique categories and find any irrelevant category if there it is. So this is a very simple trick to find the unique values, and if you have non values, then it will be visible directly from here also. Obviously, it will not be visible for your categorical data, but it will be visible for your numerical data. So our first EDA asks what is the total number of missing or unknown values in column gender. So for that you have to check what is the data type of it. Data type is object, that means it is a string or maybe date time, but date time it can't be, right? So it will be an object. So we have to check the unique values for it. And the way we are going to do is we are going to index into it. So you have to choose the column name gender dot unique. Now you can see that there are unknown values, right? So if unknown values are there, you have to check how many unknown values are there. Now there are many ways to do that. You can use log, ilog, but I try to do things simple. So I create a filter condition. Filter is equal to df of gender is equal to unknown. Now let me show you what the filter is actually. You can see that it's a boolean array having true or false values. Now we can use this for our advantage. We can directly do a filtering, df of filter. Now you can see that all these values are there, but it will not give you the length. So either you can do .shape or use the length. So you can see that we have 7 such values where gender is unknown and 11 features. So 7 because we only want number of rows, right? Now, what is the total number of missing or unknown values for column H? Here again, let's check what is the data type. It is float 64, right? So that means it is an integer. So whenever we have integer, we have to check if there are any negative values or not, or maybe there are any non values. So first of all, let's check if we can get any unique values or not. Then you will understand why I'm saying that we have to just directly go for the negative values. So if I do dfas dot unique, you will see that there are a lot of values, and clearly you can see that this is -3 and H can't be -3 or -2 or -1. Also, if you see here, it is 7.20 E minus 01. So minus is there, that means negative value will be there. It is just a scientific notation. So that's why I said that we can directly use the filtering to filter out only negative values. Okay, so I am again going to use the filter df is less than 0, and now I am going to show you a different method. Rather than creating the filter every time, I am just going to use this for my indexing thing, and once I do this, you can see that there are a lot of values, right? But what is the length? So I will show you how to get the length. The length is like length and then pass everything inside that, and you will get that 8 is your answer. That means there are 8 values where the values are less than 0. So total number of missing values for the column age will be 8. And this is very important that you do this. Now similarly, how to check for total number of missing or unknown values in the column glucose level? Again, let's check the data type of glucose column. So if you see glucose level, it is again a integer value or a float value. That means numeric value. So for numeric value, you have to use this particular property itself, right? So here I will be using glucose level. Let's check. So 9 values are such that those are negative values for glucose level. Now, how many total number of missing or unknown values in columns lives in? So let's check what is the lives in data type. It is an object, that means it has some unique values. So let's check if there are any unique values or not. So df of lives in dot unique. So you can see that here we have city, we have village, and we have unknown. Again, we saw that there is an unknown category also. So we have to extract how many values are there in the unknown category, right? So let's do that. df of lives in is equal to UKNOWN unknown dot, so it will be UN 511. So there are 5 values which are of unknown. That means there are missing values in that. Data is not there, right? Similarly, let's check for our BMI columns as well. So for BMI column, again, let's check the data type. You can see that data type is float 64, but here is the cap. Here you can directly see that there are few values that are directly missing from it, right? 4000 and 3851. So that means that we can directly use the NaN values itself from the column, and we can use the NaN values because it's an float 64 or an int data type, right? So df of BMI column indexed, then now this will be a Boolean array, and let's check the sum. So sum will take all the true values and sum it. So there are 149 values which are missing, right? Now we will check total number of missing or unknown values for column smoking status, right? So for this, we have to check the data type of the smoking status. So the smoking status is 4000 non-null values, and it is an object data type. That means again string. So we have to check the category itself, right? So df of smoking status dot value counts. This is direct way to get it. So 1, 2, 0, 4 are those values. And also for all categorical variables or features, you can use this value count to directly get the answer. It will save you a lot of time there, right? Now comes the interesting part of the EDA, taking some aggregation values and checking few hypotheses and everything like that. So let's look at those also. So now a common question that may arise is, what is the mean value of a particular column? Here we have taken BMI because BMI has some missing values or null values, as we have seen earlier also, right? So in this case, how you will get the mean value? And it says that ignore missing values if any. So the fact is that if you use the mean function on a data frame, it will directly ignore missing values. Okay, so keep that in mind. Now let's check how to do that. So I will just going to index into BMI. So df of BMI dot mean, and it will give you some value. If you are not sure what axis to use, just use axis is equal to null. So now next thing is, we might have certain hypothesis of a question, like how many people live in a city who has smoked at least once in life and had a heart attack. Also, these all columns have missing values, so we need to ignore those also. So first of all, we need to find the relevant columns which are required and create a list out of it. So few relevant columns are lives in, smoking status, and heart attack. Now, next thing we need to handle is that what are the values in this, and then we will look into what all things we can do. So rather than going upward, I am just going to print here only. So if we do df of lives in dot unique, you can see that we have city, village, unknown. After that, if I do df of smoking status dot unique, you can see never smoked, smokes, unknown, formally. After that, we can also check for heart attack. So we have our heart attack, no and yes. So now based on whatever is asked, we have to focus on that particular thing. So it says how many people live in city. So our lives in should only be city when we are filtering the data. Next, it asks for smoking status, has smoked at least once in life. So at least once means either they have smokes or formerly smoked. And for heart attack, it should have had a heart attack. So that means yes. So these are the conditions that we need to use to filter our data. By default, if we are using all these, we are directly ignoring the missing values. So you don't need to work on that particular thing. Now we have to create our filtering condition. Filter condition I use con. Okay. Now df of lives in, which is our column name, is equal to city, and make sure that you pass it in within the tuples, because these all things will return us a boolean values which will be a series. Follow this format when using multiple filtering conditions. Now for smoking status, we have smokes as well as formerly smoked. So we have two string values. So rather than checking individually, we can use is in method. So I will be using df of smoking status dot is in, and then we need to pass in an array which will contain smokes, formerly smoked. We will not handle never smoked, okay, because we want columns where person has smoked at least once in life. And finally, we have our last condition, which is heart attack is equal to yes. So df of heart attack is equal to yes. Now if I show you filter com, you can see that it is a boolean array with 4000 values, either true and false. Now we need to use this to filter our data frame, right? So df of filter on, and that means we have no values such as that. That means that we have done some error, and the error is this, that we have used capital city. So we have to use a small city, and let's check if any other errors are there also. No. So here is the issue that now if I do, you can see that there are 52 values where this condition satisfies. That means 52 values are there where people have this particular criteria. And that means that yes, your analogy was right, that there are few people who live in city, smokes at least once in life or may have left the smoke, and they had a heart attack. Now next hypothesis that you can have is which categories have highest frequency. And again, this is a filtering condition. So you have to check the columns and then you have to do the filtering conditions. So in this particular hypothesis, most of the times we are focusing on our gender, marriage. So it is very important that check the values for this particular thing. So let's check df of gender dot unique, female, male, unknown. So we can use male and female. Unknown we will drop, so we don't require actually. Now let's check for marriage. But now if you will check your data set, you don't have a column named marriage. You have something called as never married. So we have to use that particular column name, and this is why I said you earlier that please read the descriptions of all the columns. So df of never married dot unique, and you can see that it is yes or no. So if it is yes, that means that they have never married, they are singles. However, if it is no, that means that they have married or they have been divorced. We have to check another column also, right? So for tension, we have to check which column has this. So if you scroll a little bit up, you can see that there is a column name has tension. So we have to check the unique values for this also. So df of has tension dot unique. You can see that it's yes and no. So no null values or unknown values, right? So that's totally fine. Now we will use all these columns for our solutions. So first condition is female present without tension, without any heart disease, and never married. So for this, we will create a filter. So filter 1 is equal to now our failed condition is gender is female, right? So df of gender is equal to female, and df has tension is equal to no, because it says without any tension, and df of any heart disease is equal to no. So if you are saying that like heart disease is there, so that will not be your column. It should be any heart disease, because this is also a column which will tell us if we have any heart disease or not. So no. And finally, if the person has never married, so that condition is also there. So DF of never married is equal to yes, because that person should have never married. So yes, right. Now we can directly index into the columns. So DF of filter con the one. Let's check how many values are there. There are values, and if you check, you can directly see from here also that there are 1335 observations where this all conditions satisfy. So we can use .shape also, and it will make our answer succinct. That's all, nothing else. So first condition is this. Now based on this, we will check for our second conditions. So mostly all things will remain same, though we can directly copy things and change things here and there. So let's check the next one. Female patient without tension, without any heart disease, either currently married or married before. Okay, so this condition also we need to check. Rather than writing the entire thing, I'm just going to copy paste, and you can do it too also. Okay, filter condition, and here second, gender should be female, person should not have any tension, it should not have any heart disease, and either currently married or married before. So this column will go to no, because if they have never married, that means this condition will fail, right? So we have to use the no there. And if I do that, you can see that there are 754 values such that this condition satisfies. Now let's check for the third condition as well. The third condition is male patient without any tension, without any heart disease, and never married. Okay, so let's check those also. So filter condition 3, and gender should be this time male, right? It should not have any tensions, so has tension no. Without any heart disease no. DF never married, no. That means they have never married. And if I check the shape, it will be 560. So 560 value means there are 560 observations where this particular condition is satisfied. Now let's check for the fourth one also. I'm going to copy it from here, paste it here. Now next thing also we have to do. So filter condition 4. Now change the value as per the condition. Male patient with tension. So gender is male, tension, yes, this time they have tension, so yes. Then with a heart disease and never married. So with a heart disease also, right? So there is a heart disease for them, and never married. Never married means this should be yes, right? So we have done this. Now let's check the shape. There are 24 such values. Now let's look at our hypothesis. What was our actual hypothesis? Our hypothesis was which of the following categories have the highest frequency. That means how many times they have occurred. And you can see that clearly our first category, which is female patient without tension, without any heart disease and never married, has this whopping 1335 samples, which outperforms all the rest. So our hypothesis led us to a distinct conclusion that we have to focus on these particular categories and look at what all things are going on in this. Okay, next is select the column with categorical values. I'm going to show you 3 methods to do this, because all these methods has some flaws, and there is one particular method which will help you a lot in this particular thing, but for this particular data set you can use anyone. So first one being the getting the info directly, df.info, and you can see that all the objects are categorical itself, but there might be a case where few samples are like string values, few samples are like text values. So in that, it will take text by default. Okay, so in that case we have to filter based on object data type itself. So for that we can again use a particular condition. So this is the code that df.select d types include objects. So only object data type will be included and rest all will be removed. So if I do this, you can see that all these values are there and all these columns are present, right? So you can also do this like, and you will get all the columns, right? So you can just directly check from here also. And the third one, which is the best option actually to check if there are any issues or not, you can check the unique values for each of the column. Obviously this is a time consuming and tiring process, but it will yield the best results. Okay, so I'm just going to show you one. You can try every one others. So df of, let's say for gender we are going to check, so gender dot unique, and you can see that yes, they are indeed categorical types data because it has 3 categories. Similarly, you can check for all others which have object from here only, right? And you can do that. Now let's check our final thing, that is how our target column is distributed, that is heart attack, right? So we can use this column for our advantage, df of heart attack dot value underscore counts, and you can see that we can directly get the answer from here also. Anyways, here if you see, we have no values at 3806 and yes as 194. So that's the basic of our EDA, whatever we have done, but now we know what all things has been done till now, right? So we can use these all observations that we have learned from here to perform our data processing, and we are going to create a pipeline to make our work life easier. So let's look at that. Our next part is data processing, and in data processing you have all these stuff that will come into it, like you have to split your data, you have to process your pipeline. So we will look into these all things. Let's start. So in this we have to first split our data, and here we have to divide the data into training and testing set. We have to take 30% as the test set. We have to use random state as 0. Heart attack is the target, rest columns are the features. For label target vector, replace yes and y no with 0. So we have to change the labels to yes and no to 1 and 0. We have to divide the data set into training and test set, keeping the target y in stratified manner. So stratified basically helps you to capture the distribution while separating the data set. Okay. So first of all, we need to load few libraries, and these all things will be taken care by the sklearn. So sklearn imports from sklearn dot model underscore selection import train test split. Once we have that, we will first of all separate our data set. So x is equal to df dot drop and heart attack, which is our target, comma axis is equal to 1. This is to make sure that it drops the column all by itself, and similarly we will take the column heart attack in y, and you might be thinking we are dropping it, so how can we get the heart attack again? So this will return us an copy and it will be stored in x, so it will not cause issue to our df. Okay, so df of heart attack. Once we are done with it, we will split our data. So next, if we will check the y, it will be like no and yes. We need to convert that also, right? So convert y, and the easiest way to do is using the replace method. So y dot replace, it will take a dictionary where key will be your current value and the value will be whatever you want to encode it with. So yes as 1 and no as 0. Once you are done with it, your y will be replaced, and let me show you what your y will now look. So y will look like 0 and 1. So wherever there is no, it will be 0. Wherever there is 1, it will be 1. Okay. So now let's split our data. For this, we will use simple method xtrain xtest ytrain ytest is equal to train test split, and we need to pass bunch of parameters here, x comma y comma, we have to set our test size also, right? So test underscore size is equal to 0.3 because it says that we have to take 30% of the data as test set. Now random state is equal to 0. Again, it is asked in our given instructions. Next, we will set our stratify, which will be done using stratify parameter. Stratify is equal to y. So now you have your xtrain, xtest, ytrain, ytest. Now let's check the shape of it. So xtrain dot shape, ytrain dot shape, xtest dot shape, ytest dot shape. So x will be capital by the way. Now you can see that it matches, right? So 2800 comma 10 for our features and 2800 for levels. Similarly, same for y. Okay. So this is how you will create your data set. Don't use it directly. You have to replace it also. Okay. So once you have done that, we need to create our processing pipeline, which will also perform all the operations, as well as while doing all the operations, we have to handle the unknown values as well. So for this one, I have already written the code. I am just going to take it from there and paste it here, but I will be explaining you whatever we are doing. Okay, this is just to save time. So this is how I did it. It is very simple and you can also do it very easily. First of all, import the pipeline. So pipeline will help you to organize things. Next, import the simple imputer from sklearn.impute because it is an imputation process. Now for pre-processing, you have to import ordinal encoder, one-hot encoder, standard scalar, and min-max scalar. The reason we are doing it because it is said that in our pre-processing pipeline, we have to follow this, right? For gender, impute most frequent ordinal encoder, standard scalar, min-max scaling, and normal simple imputer. All those things are there, right? Then for combining all the pipelines, we will use a column transformer. It will return us a pre-processing step in a sequential manner. So everything will go one by one, okay? Now, next thing is you can do whatever way you want, but what I do is for each of the processing, that means for each of the columns that we are going to use, because we are using column transformers, right? So I'm going to create a separate pipeline for it, and then I'm going to merge everything at the very end. So first of all is gender pipe, that means gender pipeline in simple sense, okay? So I will be using pipeline, and pipeline will ask you for two objects. First one is the name for that particular step, and second one is the entire method. So for the first one, it says that we have to use the most frequent then ordinally encode. So first of all, we need to find the most frequent one. So simple imputer we can directly use to do it, and strategy will be the most frequent one. But we have to also fix the missing values. So gender has this unknown category, right? So we need to fix that. So missing values we passed as unknown. If you don't pass this, it will cause an error. So make sure that you pass this, even though it might seem that you are already done with that, but please pass this, is very important, okay? And then we will simply do a ordinal encoding. Similarly for age also, and whatever we are going to do is we are going to do using this particular thing only. So here it says impute with mean, then standard scale. So age we will impute but with the mean as per what said, and missing values is -3. So how I got this missing value? That is a one question that one should always ask, right? So here it is very simple. You have to check first of all the age, right? And you know that age has this property of less than 0, okay? So if I do df of age less than 0, which was done earlier also, you can see that all these values here are -3. Obviously, it will not work as always as you want. For that, you have to create a separate pattern. But for this particular data set, we are lucky. And it also shows us a pattern that if this particular age is not given, then heart attack is mostly no, and only few samples have yes, okay? So this is how I got this. You can do it similarly with others also. We'll look into that when we come to that. So missing value is 3, and then we standard scaled it. For the tension, that has tension column, again it is a pipeline, and we have just used ordinal encoder on it. Why? Because here it says ordinally encode. Ordinally encode will do what? It will just encode the categories in an order. This is just to ensure that whatever data you are passing as numbers, okay? Similarly for any heart disease, yes, no. So again ordinally encode. Never married also ordinally encode. Now for occupation, it is one hot encoder. The reason we are using one hot encoder is because if you see here the output, what we wanted in as per the instruction is like occupation, government job, occupation never worked, occupation private. So this is only possible using the one hot encoding. So one hot encoding will help us to create these things, okay? So that's why we are using it. So one hot encoding also done. Next, lives in. So lives in is again city, village or unknown. So unknown is there, so that's why we will ignore that and handle the missing values unknown. We will just simply include that, and we will just impute it with the most frequent. This is again given in our instructions only. Impute with most frequent, then ordinally encode. After that, we will do a glucose level pipe. That means we will handle the pipeline for glucose level, and there again we will be having the missing values -2. Again, same method that I showed you earlier. You can do that yourself and check that missing values will always be -2 for this particular data. So keep that in mind. When you find the missing values, you can directly drop them, okay? Or impute it directly. Next, you have min max scaler, which is a minimum maximum scaler, and scales your value between 0 to 1. And this is to ensure that your glucose level values are within the bounds of 0 and 1. It is very easily comparable for the model. Then BMI pipe, again similar thing, simple imputer we are using, and standard scaler. Again BMI has this null value, but we are not using unknown. Why? Because by default pipeline will automatically handle those things. Apart from that, smoking status pipeline, imputer, simple imputer, most frequent missing values again unknown, because our smoking has this age status, right? There was a column, a category name unknown, so that's why. And all these things, once you are done with that, we are going to create our column transformer. So these are things we have done without any column names, right? Because we have just said that these are the pipeline and this is the variable which will hold it. And the reason I am using this thing just to ensure that I am using the right column name whenever I am going to create the column transformer. So here in this column transformer, again we will using column transformer and combine everything out. Okay, so first one is gender. So column transformer actually asks you for three things. First, the processing name, then whatever function you want to apply, you can directly use all these things within this only, and the column name. If you have multiple columns within it, you can use comma and pass in, and it will apply it sequentially. Means first this will happen, then this will happen, this will happen. And the reason we are using column transformer is because it says that it is very important that we process all these in an order. Okay, that's why we are doing it, and it is always good practice to perform all these things in order, because that might cause issue if you don't do that. So anyways, this all done. So here whatever we have done earlier, we are just going to add a column name to it, and then we will be doing it. But at the last we have this thing, verbose features name out. So this is false, and this is a parameter which will help us get the one hot encoded values or anything like that. So let me now run all these things, having understood everything. Let's check if we are getting something or not. And now finally we are processing our data. So rather than using fit and then transform, I'm directly using fit underscore transform, and the entire thing is under the preprocessor. So I can do preprocessor.fit underscore transform extreme. And now let's check if it actually transformed my data. So you can see that there are arrays. Our column names are removed, right? Now let's check the shape of the matrix for the training data. So it is very simple. Just use xtrain processed dot shape, and you can see that it is 2800 rows and 16 features are there. That means whatever we have done, it has actually created all those 16 columns. Okay, so next is what is the mean of the transform data set. So first we need to transform this particular data set. So for that we can use the preprocessor that we have defined earlier and pass it a xtest, right? Preprocessor dot transform. Don't fit it because we are using anyway to test data set. Okay, so xtest, which is our features, because we will not be transforming our labels anyways. Xtest transform. So this is the variable which will hold it. And now if I do a mean on this and I set access is equal to none, so that we get the entire mean, not a single column or row mean, you can see that we have 0.2462. Now last thing is, before doing anything, we need to reduce the number of columns, because all these things will take a lot of space and you need to handle the space also. So for this we will use the recursive feature elimination, which will remove a particular feature, and for this it will require us to use a model. So best one is to use logistic regression, because it is the most simple and most explanatory one. Okay, so first of all we will need to load two particular libraries. First one is from the feature selection we will import RFE, and second is logistic regression from linear models. So from sklearn dot feature selection import RFE, and from sklearn dot linear underscore model import logistic regression. Once you are done with that, now we need to check if our data type is integer or not. So for that we will use whitetrain dot info, and you can see that this is an object data type. That means we need to handle this. So for this we need to convert it to an integer value. So whitetrain is equal to whitetrain dot as type int. And now if I show you whitetrain dot info, you can see that it's integer 32 bits. That means yes, it is converted to integer. So this is very important step, so make sure that you do this, because while you were doing all these things you forgot that you need to handle this whitetrain also as an integer. Now we will create our RFE object and logreg object. So logreg is equal to logistic regression, and we have to use the random state is equal to 1729. Once we are done with that, we need to create a RFE object as well, right? So RFE is equal to RFE, and it will take a lot of parameters, but first we need to give it a estimator. So estimator is something that will be used as a model for running RFE and getting the feature importance. So if a model doesn't supports the feature importance directly, mostly not tree based models, then you can use RFE to get it. And now how many features we need to select? So n features to select is the parameter for it, and it says all those except one. So not hard code it, but take the shape and remove one value from it. So extreme dot shape, and this shape will return as a tuple, so we need to index into the number of columns because we want features, right? So columns, that is the first index, minus 1, so this will reduce to 1 column. So if you see earlier it was 16, and this is the number of features that we want. It is not like it will process only these things, so keep that in mind. And once we have done this, we are good with RFE. Now we need to run the RFE, and the way we are running the RFE is using the same fit method we have been doing earlier. So RFE dot fit extreme processed comma y train. Per the instructions, it is very clear that we have to apply recursive feature elimination. So we will not be using actual dataset, right? Because it will not have 16 columns. So there's no point of using it, okay? So that's why we are using. Now once we are done with that, we have our RFE object, I have run it, and now we can get the removed index. So there are two ways to do this. First, get the support value. So RFE dot support underscore, this is an attribute, and you can see that there are many values which is false, 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 and false, right? So might be there's some problem. So the problem is that we have to use extend process because we are fitting that particular data in that, right? Now if I do this, you can see that at this particular only it is false, and when I do RFE ranking, you can see that it is 2. That means all the ones are important and 2 is the least important one. So we can drop this particular column. And if you see the length, it will be like 15. Okay. So that's the crux. And now you can use all these columns for your model building. All those things that we have done here, I hope it would give you a good, better idea for all the things that you have been asked to do, as well as you can do whenever you are doing your personal projects. Obviously, this was a very long video, but I hope that you got some value. And here are a few resources that I would like to share. First one is that you need to learn the basic data manipulation using Pardis. You can learn basics, learn the basics of scikit-learn. Here, I have just provided you the entire API link. Go through it, check out what are other parameters that you can use to ease your process. And the companion notebook is also being shared. So you will get this notebook also in the description. So with this, we have come to end of this particular session, and I will see you in the next video. Till then, see ya. Bye-bye.